So in this last video, I'm going to answer the last question that was on, or the next question that was on your question sheet, and that was to show where you get ATP from the oxidation of a 16 carbon fatty acid. So I've left the Krebs cycle up here. I've taken off all the carbohydrate stuff, so I've taken off all the glucose metabolism. I've left the Krebs cycle up here because that's involved in fatty acid oxidation. So you get a 16 carbon fatty acid that's going to enter the mitochondria. So this entire square represents your mitochondria. I'm going to just draw the 16 carbons up here. So there's your 16 carbons. That's the chain in your 16 carbon fatty acid. So I haven't drawn the entire fatty acid, just the 16 carbons. That is going to go through beta oxidation as your first aerobic pathway. So it goes through beta oxidation. And for each round of beta oxidation, you're going to produce one NADH and you're going to produce one FADH. So the NADH again is going to go to the mitochondria, or going to go to the electron transport chain and give you 3 ATPs. The FADH is going to go to the electron transport chain and give you about 2 ATPs. So this beta oxidation breaks down the 16 carbon fatty acid 2 carbons at a time, and then the 2 carbons that are broken off each time goes to acetyl-CoA and then goes through the Krebs cycle. So for beta oxidation, you get this 16 carbon fatty acid being broken down 2 carbons at a time, just like this. So you end up with, for 16 carbon fatty acid, you end up with 1, 2, 3, 4, 5, 6, 7 rounds of beta oxidation. So it's not just simply 16 divided by 2 because you have 2 carbons left over at the end. So it's not, the answer is not 8, it's actually 7 rounds of beta oxidation. So you get beta oxidation, just adding up the ATPs here, you get 7 times NADH, and then you get 7 times FADH. For each NADH that goes through the electron transport chain, you get 3 ATPs, and then for each FADH, you get 2 ATPs. So you can see just from the beta oxidation, you end up getting 21 ATPs from your NADH and 14 ATPs from your FADH. Now, each of these 2 carbon molecules that's chopped off of the fatty acid chain is going to form your 2 carbon acetyl-CoA. So you end up having 1, 2, 3, 4, 5, 6, 7, 8 acetyl-CoAs that get produced from the breakdown of that fatty acid. So you have this Krebs cycle go around 8 different times. So you have 8 times your Krebs cycle. This is for your NADH, so you have 3 NADH that are produced here in the Krebs cycle. You have 1 FADH, and then you have ATP, an ATP equivalent that's produced at 1 step. So 8 times 1 ATP. So you end up with 8 ATPs obviously from that step. End up with, this is going to be multiplied by 3 ATPs in the electron transport chain. This is going to be multiplied by 2 ATPs. So you end up getting 8 times 3 is 24, times 3 would give you, I think, 72. Let's see, 24. Yeah, that's 72. And then you get 16 ATPs here. So if you add that up, you'll get approximately your number of ATPs that are produced from the oxidation of one 16 carbon fatty acid. So if you add it up, it's going to come out to well over 100 ATPs. So you can get a lot more energy from breaking down one molecule of fatty acid than you can from one molecule of glucose. So there's all of your ATPs. Again, just to recap, 21 plus 14 from beta oxidation, and then all these steps here come from your Krebs cycle. So you get the 8 times 3, 8 times 1 FADH, 8 times 3 NADH, 8 times 1 FADH, 8 times 1 ATP from the Krebs cycle. And then these top two here, the 7 NADH and the 7 FADH, come from your beta oxidation.